Welcome everyone. Today we're diving into the world of PhET interactive simulations, an engaging interactive way to explore science and math concepts. Whether you're a student, educator, or just curious, PhET makes learning both accessible and fun. In fact, PhET interactive simulations is a solution to science and math without a laboratory in Papua New Guinea. In this video, I will guide you through its accessibility and usage. Before we dive into the world of PhET simulations, let me introduce the team behind the production of this project.
I'm Louisa and I am the research coordinator. I am Dulcie and I am the content creator.
Hi, I'm Jessica. I'm the scriptwriter and the content creator.
I'm Benny. I'm the editor and the reference support.
And I'm James. I'm the technical lead or the designer of this project. Now to PhET interactive simulations. What will you need to access PhET interactive simulations? Well, you only need a smart device with a browser software. Examples of smart devices include laptops, tablets, and smartphones, or any other device capable of running a browser software. Examples of browser softwares include Google Chrome, Microsoft Edge, or the most popular Google browser, which is often pre-installed in many smart devices. That's all. No test tubes, no meter rulers, no flasks, no force meters, etc. Just a smart device with a browser software. Since we are talking smart devices and browser softwares, we will obviously need internet connection as well. Accessibility and usage is actually very simple. Once you are connected to the internet, open your preferred browser software and type in PhET interactive simulations in the search bar. Let me show you how that can be done. Once you are connected to the internet, open your preferred browser. Here I am using Microsoft Edge, so I will click on it and type in PhET interactive simulations. I'll click on the first option that appears, and there. I now have access to PhET interactive simulations for science and math. There are a few drop-down menus on the top right-hand corner. Simulations, studio, teaching, research, initiatives. What we will be exploring in this video is an example of the usage of a physics simulation. But before we do that, let me share some amazing news about PhET interactive simulations. This platform has delivered over 1.7 billion simulations covering the core science subjects and mathematics. Teachers and students from kindergarten to universities rely on these freely available simulations to run lessons, assessments, practicals, and so on. Additionally, there is a community of users that prepare activities suitable to their context and upload them on the PhET website. Any other users can access these activities and modify to suit their own context and use them. It's as easy as that. You can register to create your PhET account either as a teacher, a pre-service teacher, translator, or any other person and have access to all that PhET has to offer. Now to a sample physics lesson. I am going to demonstrate the usage of PhET interactive simulations through a simple physics lesson based on the topic of electricity. The title of this lesson is Measuring Electric Current and Voltage in a DC Series Circuit. To begin, hover your mouse pointer over Simulations. On the drop-down menu, click on Physics. As you can see, there is a total of 64 simulations under physics. A variety of simulations under physics cover motion, sound waves, and so on to electricity, magnets, and circuits. Since our lesson is based on electricity, we are going to uncheck all other simulations except electricity, magnets, and circuits. That narrows the number of simulations down to 16. We can now scroll down and find a simulation that is suitable for our purpose. Circuit Construction Kit DC is the most suitable for our lesson. Click on it and you will be taken to the appropriate simulation. The topics that can be explored using this simulation include series circuit, which is what we will explore in this video, parallel circuit, Ohm's law, and Kirchhoff's law. Sample learning goals are also listed for us. You can add, remove, or modify these goals to suit your specific needs. If you wish to work offline or without internet connection, you can download the simulation by clicking the download button. It's just a simple 3 megabyte file which you can repeatedly use without internet connection. If you wish to work online, which we will do now, you can click on the play button like so. Click on the lab option and you now have a virtual space to conduct your lesson. For this demonstration, I am going to construct a series circuit using the following circuit components: 2 times 9 volt dry cells, 2 times light bulbs, 1 times switch, and connecting wires. And then I am going to use emitters to determine the current in the circuit and a voltmeter to measure the voltage or potential difference across each bulb. To save time, I have prepared the series circuit with all the required components beforehand. The only components we do not have in the circuit is the second 9 volt dry cell and the voltmeter. I will now connect the 9 volt dry cell. We now have a complete circuit. Let us switch it on and see if it is working. Perfect. Since it is a series circuit, the current going into the circuit is the same as the current coming out, and that is clearly shown on the emitters. Emitter number 1 reads 0.6 amps, number 2 reads 0.6 amps, and number 3 reads 0.6 amps. The current going into the circuit is the same as the current coming out of the circuit. Let us determine the voltage across each light bulb. To do that, we drag out the voltmeter and connect it appropriately to the light bulbs. The black probe represents the negative terminal of the voltmeter, and the red probe represents the positive terminal of the voltmeter. The voltmeter must be connected correctly for it to give the correct voltage value. We will connect the black probe to the negative end of the dry cell, negative end of the dry cell, negative probe of the voltmeter. And we will connect the positive probe of the voltmeter to the positive end of the dry cell. Positive end of the dry cell, positive probe of the voltmeter. As you can see, the voltage across this light bulb is equivalent to 6 volts. We will apply the same thing to the second light bulb. But do not forget the voltage reading on the first light bulb, which is 6 volts. On the second light bulb, we have a voltage of 12 volts. Since both bulbs are connected in series, the total voltage should be equivalent to 18 volts. How do we determine that using the voltmeter? We can simply connect the negative terminal to the negative probe and the positive terminal to the positive probe of the voltmeter. There we have 18 volts, which is the total voltage applied to bulb number 1 and bulb number 2. And that same 18 volts is the voltage provided by the two dry cells that have 9 volts each. To change the voltage on the battery, you can simply click on the battery and see the voltage here. You simply drag this to increase the voltage and decrease the voltage. Alternatively, you can use the arrows to increase the voltage and decrease the voltage. When you increase the voltage, you can see changes on the emitter and on the voltmeter. Notice the brightness of both bulbs. Bulb number 1 has a brightness that is less than bulb number 2. What does that mean? Okay, that simply means one bulb has more resistance than the other bulb. To know how much resistance each of the bulbs carry, you can click on the bulbs to see their resistance values. The first bulb has a resistance of 10 ohms. The second bulb has a total resistance of 20 ohms. Depending on your lesson plans, you can write down certain questions or test out certain parameters of the series circuit to prove if laws like Ohm's law is true in such cases. That brings us to the end of our session on accessibility and usage of PhET interactive simulations. From the Stimulate Physics team, we wish you all the best in utilizing this powerful tool to impart and gain the much needed 21st century skills for an intelligent future. Thank you.